Yes, yesterday we have ended up with the PO Mathematics 1, the integration part. So there, I think if we can manage the sections that we have done. So you have to finish your homework with that. Today we'll be starting with PO2 Mathematics, this integration section, right? So yeah, we'll start from there because that's a continuation of the PO1 Mathematics integration. So we can start from that. Right, I'll just start with 170, like, yes, it's there. Yeah, in this topic, but mainly we are prioritizing with the integration called the finite integral. So you have to understand what we mean by this finite integration with it. This finite integration means so in the same thing as a usual integration, the same integration type. So they might give you a question like this: x squared plus 2x plus 1 from they have given the boundaries from 1 to 2 dx. Usually the writing dx is the fact which mention you need to integrate the x terms only. Later on in our A2 level we learned there are some facts where I have to come up with a different variable integration as well. So those things you cannot integrate from here, right? Okay. So how to do this integration is you have to follow up the same sequence. Initially we have to just integrate as usual what we did with it. So here this is x cube over 3 plus this is 2x squared over 2 and plus 1 integration is x. In this case, but then no need of writing plus c at the end. Right. Then we will put the boundaries over here, 1 and 2. Right. Then initially what you need to do is put a substitute this upper boundary into this range. Substitute the upper boundary. So if you substitute upper boundary is 2. So you can say 2 cube over 3 plus 2 times of 2 squared over 2 2 squared over 2 plus 2. So this is the substitution of the upper boundary. Same thing what I did in the last session. Do the usual integration, then substitute upper boundary, then minus. This is the important point. Then substitute the lower boundary. What is the lower boundary over here? Lower boundary is 1. So you can put 1 cube over 3 plus actually not of writing this 2 and 2 both. So if you want you can cancel out here, but since I written over here I just tried it. So you can say 1 squared over 2 plus 1, then you get the answer over here with it. So if you simplify this, you can get the answer. Right? Give me 1 minute. Yes, if you work out with this, you will receive this answer from, this is from 2 to 1. Yeah, the answer become 19 over 3 today. So the answer would be over here. It is 19 over 3 is the final answer for this. That's a way of doing this. Right? Okay, this is pretty simple. Let's go to another question and let's try to understand how we're supposed to do. Suppose that we need to integrate this one. So second example is integration from 1 to 4. We'll get a little bit of advanced question. X plus 1, 2x minus 3 over square root of x dx. So when you happen to do this question, but initially what you need to do is we have to simplify this. I'll do the simplification over here. So if you initially take x plus 1 times of 2x minus 3, you have to remove the brackets. If you expand the brackets, that is turn up to 2x squared minus 3x plus 2x is minus x minus 3. So x into 2x is 2x squared, x into minus is minus 3x, 1 into x, 2x minus 3x is minus x, 1 into minus 3 is this. Then you can divide by x, square root of x. X plus 1 over 2x minus 3 divided by Square root of x is the division of this one from square root of x. Then we know that what is the square root of x? Square root of x is x to the power half. That means you can divide these individual terms by x to the power half. So this answer you can write, this is 2 x to the power 2 divided by x to the power half minus x to the power 1 divided by x to the power half minus 3 divided by x to the power half. So still not integrating, but I'm just simplifying this. 2, if you divide the powers get subtracted, 2 minus half is 3 over 2. Minus, this is x to the power 1 minus half is half. And you can bring it up and you had write minus 3 x to the power minus half. Always you need to write, this is half, sorry, half. The requirement is always you have to, for this integration purpose, you have to convert the integration of x to the power n format. Then only you can put into the formula n plus 1 over n plus 1. So that is a requirement of converting all of these facts into this format. So yeah, then it just is a formula, integration formula where we were doing. So we need to work out with that, right? Okay, that's a requirement for that, right? Okay. Then we can do this integration now. It's already converted to that form today. 1 to 4. This is 2x to the power 3 over 2 minus x to the power 1 over 2 minus 3x to the power minus 1 over 2 dx. Writing the dx is factor to mention that we are integrating x to the power x terms in this integration. That's what you mean by this integration indicates you. So if you do this integration with it, 2 x to the power 3 over 2 plus 1 is 5 over 2 over here it's 5 over 2 minus x to the power half plus 1 is 3 over 2 over 3 over 2 minus 3 times of x to the power minus half plus 1 is plus half over plus half. Then you can put the boundaries with it. 1 and 5 mentioned in the previous case. For the finite integration, we won't put c at the end, right? Then this is numerator, denominator. Again, this 2 goes up because it's numerator with it. So this is turned up to 4 over 5 x to the power 5 over 2. Right? That is how it comes. Minus here also this 2 goes up. 2 over 3 x to the power 3 over 2. And this 2 goes up. Minus 6 x to the power 1 over 2. From 1 to 4. Right? Okay. Then what you can go ahead here is, so you can substitute the upper boundary 4 over 5, 4 to the power 5 over 2, minus 2 over 3, 4 to the power 3 over 2, minus 6, 4 to the power 1 over 2 is upper boundary substitution, minus then substitute the lower boundary. The lower boundary is 4 over 5, 1 to the power 5 over 2, minus 2 over 3, 1 to the power 3 over 2, minus 6, 1 to the power half, that stuff. So with that, you can get the final answer in this format. But if you just work out integration from this is 4 to 1, the fraction, it's alpha. So the answer become 212 over 15. If you simplify this, you will realize that the answer become 212 over 15. This is a final answer for that. That's a way of doing this ones. Right. Okay. Yeah. Then that is a way of doing this finite integration. So pretty simply, with this, you can find the finite integration for that. So remember that when you do this integration, there is one more thing you have to put it. Usually for the upper boundary become, for this case, the larger value become the upper boundary and the smaller value become the lower boundary. But there are some exceptional situations where we learn in our A2 level. When you substitute anyway, you have to put the upper boundary as a larger value and the smaller value as the lower boundary. But during intermediate step of the integration, there are some situation comes, these two can interchange. Sometimes this goes down and this goes up. But when you do the sub, what do you call that? At the beginning of the question, definitely you need to write the upper boundary at top and lower boundary at the bottom. That's a concept we have to understand. Okay, right. Let's go to the application part of this finite integration. Yes. So you can say applications of finite integration, right? Okay. What are these applications of this finite integration? Suppose that yes, just like this. This first one is there is some kind of a graph, just like this. Suppose that this function is fx, and you need to find the area over here from A to B. Yes. So suppose that I need to find this area. I need to find this area over here. So simply, you can find this area by this formula. So what you need to do is simply you have to integrate this function fx from A to B dx. From this pretty simple formula, we can find the answer for that. Right. Okay. Let's go ahead with few examples and try to understand this concept. Right. So let's see the first example we are referring to. There is a graph. The equation is y equals to x plus 2, right? Suppose that they need this area to find. Here, this is 1, 2, yeah. Suppose that I need to find this area. The question is, find the shaded area, right? That's a question. So simply you can just label this one as A. So you can write A is the integration from 1 to 2 fx. The function is x plus 2 dx. So simply this is turned up to x squared over 2 plus 2x, the integration from 1 to 2. So you can say this is 2 squared over 2 plus 2 into 2 upper boundary substitution minus lower boundary substitution. 1 squared over 2 plus 2 into 1. So if you do this integration, you can simply get the answer for this area 2 to 1 alpha x plus 2. So that is 7 over 2. Area become 7 over 2. Yeah. Let's go ahead with another example. Right. Okay. Example 2. Right. Then suppose that there is a curve somewhere like this. This curve is y equals to x squared minus x minus 6, right? What do they need is they need to find this area. We'll get some kind of a very colorful one. Yes, that's it. Right. Okay. The question is we need to find this area. Right. The question is find the shaded area. Find the shaded area, right? Okay. Then how do we supposed to find the shaded area, Pratik? Yes. Right. To find the shaded area, that is a problem. But there's a small issue right now. We need to find what is the coordinate over here and what is the coordinate over here that is required. Then how do you supposed to find this coordinate? Right. You can understand that I'll just label these points as A and B. So you can say, because to find this integration of this area, so you can simply say this area is the integration of x squared minus x minus 6 dx from where to where? From A to B. That gives you the shaded area. But anyway, now you need to find the x coordinates of this one. So you can simply say at A and B, what happened? The curve meets x-axis. If any curve meets axis, what is the theory we know? If any curve meets x-axis, the theory over here is the y-coordinate becomes 0. So you can say x squared minus x minus 6 equals to 0. That is x minus 3. If you factorize it, x plus 2 is equals to 0. That is x equals to 3 and x equals to minus 2. So here this coordinate become, simply we can get these values. Yeah. So now the A coordinate is how much? The A coordinate become minus 2 now, minus 2, and this become 3. So simply you can get this answer. So now you can do this integration from where to where? Minus 2 to 3. So if you do the first part of the integration, that is x cube over 3 minus x squared over 2 minus 6x from minus 2 to 3, right? Then what you need to do is you have to substitute the boundaries. Substitution of 3 put 3 cube over 3 minus 3 squared over 2 minus 6 times of 3, substitution of the upper boundary minus the substitution of the lower boundary. When you substitute these minus values, remember you have to put a minus. So you have to put a bracket over there, not minus. Divide by 3. Other than that, you get a wrong answer in the calculator. 2 minus 6 times of minus 2. So that is what. So you can get the final answer with this. If you do this integration, so it's from so you get the answer 125 over 6. Yes. Here you get a minus answer. This one, I think I made a mistake when you're drawing this graph. I think, is this graph clear? Is this graph correct, which I already drawn? No, there's a problem with this. What is the problem with this graph? But the actual graph for this is just like this. It's not this graph. So this is wrong. This part you can say like this. The actual graph is like this way around. X squared minus x minus 6 graph is like this. It's a graph somewhere like this. I just, yeah. So therefore the area become this bit. So that is a pointer to understand. So when you do this integration, there is a one more fact where we can understand what is that is, that means, yeah. Right. That is, if the graph goes underneath of the x-axis, that area obviously become what? That area obviously become negative. That's a fact where we can understand. So that is why you get a negative answer here, because it's below than x-axis. The graph goes underneath of the x-axis, right? Let's go to another example. If you go to the book, the questions, it's just like this. Metanati have given this examples to check with these integrations. Let's go ahead with some questions with this area under the graph. So if we come up with this question today, yeah, minus 20 minus x squared. Yeah, so over here, y equals to 20 minus x squared. They ask us to find the area enclosed by the curve and x-axis. That's a question they have given. So simply if you draw this graph, it's a graph somewhere like this. Graph again. Over here, then we need these coordinates. How to find these coordinates? So they ask about area enclosed by the graph and the x-axis. That means what is the area they are referring to? They are referring to this area they consider. Is the fact they are worrying about this part of it. But then can you see the color difference when I am making with the different colors? Different colors. Children, can you see them clearly?
Yes, sir.
Yeah, no, it's not a problem.
Yes, sir, we can.
Yeah, right. Okay. Then we need to find these coordinates. But how to find these coordinates? So I just label this one as P and Q. P and Q. So you can write at P and Q, the curve meets x-axis. If any curve meets x-axis, what you can say? The y-coordinate becomes 0, right? The y-coordinate becomes 0 means you can say 20 minus x squared is equals to 0. So if you get this fact, so if you factorize it and if you get it, you will get the answers as minus 1, and 20. You get the answer 4 and minus 5 with it. So over here, the answers become x equals to 4 and x equals to minus 5 with it. So that this coordinate become 4 and this coordinate become minus 5. So if you need to find the area, what you need to do is you have to integrate it from minus 5 to 4. Minus 5 to 4, 20 minus x squared dx with it. So simply what you can get here is, if you integrate it, this is 20x minus x squared over 2 minus x cubed over 3. This is 2 with it. 2. From where to where? Minus 5 to 4. And substitute 4 minus 4 squared over 2 minus 4 cube over 3 minus over here you can put this for minus 5. So when you substitute in minus 5, as I mentioned, you put a bracket. Other than that, you get a wrong answer when you introduce the calculator. 2 minus 5 cube over 3. With that, you get the final answer. You will get the final answer as 41 square. If you simplify this, 20 minus, you get the answer 243 over 2 Pute. So you can understand that Pute, this is above the x-axis. 243 over 2. Yeah, 2. 2, right, okay. So you get a positive answer over here. This is positive. Positive means what happened? Definitely you can say that it witnesses from here. Its graph is above the x-axis. It's above the x-axis. Therefore, definitely you should get a positive answer for that. Right? Okay. Then let's go to a few more examples, questions in this exercise. So I think you can do these, the first few questions. So just you try out those things, and if you have any doubts, just pass in the next class. So I'll be straightforward going to this question number 4 today. This question number 4 is given that a is a constant and integration from 4 to 1 6 square root of x minus a dx. A is just a constant like 5 6 value. This is just a constant. Show that there are two possible values. So a and find these values. The question is 6 root. This is exercise 8a, question number 4. 6 root x minus a. So the question is 6 root x minus a dx. This is equals to a squared from 1 to 4. That's, I think that's a question. 6 square root of x is a squared. Find the possible value for this. So over here, but this is I'm just referring to exercise 8a, question number 4. Right? Yes. Yeah, question number 4, right? Okay. Now let's see how to do this question, Pute. Simply what you need to understand is, Pute, this a is just like constant, just like 5, 6, 7, or something minus or whatever it comes like that, Pute. So what you need to do is initially we'll do this integration, Pute. So here what you need to understand is, Pute, this one is what is that? X to the power half. So no need of writing it again, you can just do it, Pute. 6x to the power half plus 1 is 3 over 2 over 3 over 2 minus ax. If you integrate ax means if you integrate 5 minus 5 answer is minus 5x. And if you integrate minus 10 answer is minus 10x, like that. If you integrate my a it's just a constant, so that is turn up to ax, right? Okay. Then we, if you just do this, but you can understand it, this is this 2, this 3 go up, numerator, denominator, get this numerator, 12, 12 divided by 3 is 4. So that is 4 x to the power 3 over 2 minus ax from 4 to 1, right? Okay. So with that, if you substitute 4, if you substitute 4, 4 into 4 to the power 3 over 2 minus a times of 4, substitution of upper boundary minus substitution of the lower boundary with it. 4 1 to the power 3 over 2 minus a times of 1, right? Okay, so if you do this, 4 to the power 3 over 2 is 8, 8 into 3 is 32, 32 minus 4a minus, if you substitute 1 it's 4 minus a, right? So if you do this, answer is 32 minus 4 is 28, minus 4a minus minus 4a is plus a, it's 3 minus 3a, minus 3a. 4a minus minus a is plus a, 4a plus a is 3a. Now they have given that, this part of it. Now they have given this answer is a squared. Therefore you can write 28 minus 3a is equals to a squared. Then bring all the terms to one side. That is a squared plus 3a minus 28. So here this is a squared, if you factorize it, plus 7a minus 4a minus 28. This is a plus 7 and this is a minus 4. So answer is a is equals to 7 and a equals to a equals to minus 7. This is minus 7 and a equals to 4. These are the answers for this question. Okay, that's a way of doing this kind of a question, right? Okay. Yes. Here, if you come up with a question number 6, evaluate 12 to 4 2 root x. 12 to 4 2 root x. Question number 5. If you do this question 5, question is 12 to 4 12 to 4 2 root 2 of root x. 2 over root x dx. So you can understand that this is this way, 4 and 12, this is 2x to the power minus half. Because we cannot integrate 1 over root x or anything, so it can turn up to 2x to the power minus half plus 1 is plus half over plus half from 4 to 12. So answers become numerator, denominator, again these two goes up, 4 root x, 4x to the power half, 12 to 4, right? So with that, if you substitute these facts to this, 4 times of 12 to the power 1 over 2 minus 4 times of 4 to the power 1 over 2, right? So here this is 4 into 12 to the power half is square root of 12. Square root of 12 is put there 2 root 3. 2 root 3 minus 4 to the power half is 2. 2 into it's 8. So answer is put there 8 root 3 minus 8. That's the final answer for this put there. Yeah, so that is the way they want this answer in format of it. Here also the question number 7, 8, all the things should be done in this one, right? If you come with the question number 8, but they quickly will finish it off. The speed v of a train is given for the range of 0 to 10, v equals to 20 plus 2t. The distance s is travel in 10 seconds is given by 0 to 10, 20 plus 20. That's not a hard question, so you can just do the integration and can obtain this answer, the distance travel. Later on, we will use this fact to understand about this integration. So this question we did. And here what you need to do is this part of the question, we need to do this integration from minus integration of minus 3x squared plus 17x minus 10 from 1 to 3. This one integrate from minus 3 to minus 1. You can do this part. Over here, the sketch show the part of a curve with the equation y equals to x this much. Find the area of the region. Here, if you need to find this region, yeah, here you need to understand that this coordinate is how much? Here the coordinate is 0. So with that, you can find this area, the shaded region area A. This area A, you can find integration from minus 2 to 0, this graph with it. X times of x squared minus 4. Anyway, you have to simplify this. Minus 2 to 0, this is x cube minus 4x dx. So from this integration, you can get this answer. Right. Okay. Over here, if you need to find the shaded region R, what you need to do is, this R is the integration from 1 to 3, 3x plus 6 over x squared minus 5. So you cannot integrate this one straightforward. Therefore, you need to convert into x to the power n form. 1 to 3, this is 3x plus 6x to the power minus 2 minus 5 dx. That's the answer for this. Then they ask about find the area of the finite region with a curve with the equation 3 minus x 1 plus x. So if you sketch this graph, it's a negative graph with a negative coefficient. So if you sketch this graph, it's a graph somewhere like this. It's a, here you can see if you expand this, it's a coefficient of x squared is negative. Therefore, it's a graph with a minima. So if you sketch this, you can see it's a graph like this. Whereas here the coordinate is, sorry, this is not the graph. It's the coordinates are wrong. Minus 1 and 3. So here it's, the shape is correct, but the coordinates are wrong, right? The shape is like this. It travels through minus 1 and plus 3, just like this. Here the coordinate is minus 1 and here the coordinate is 3. So they are referring to this area. What you need to do? You have to integrate from minus 1 to 3. This is 3 minus x times of 1 plus x. You cannot integrate straightforward. So you can do from minus 1 to 3. If you expand this, it's 3 plus 2x minus x squared dx. That is the answer for that. That's how it comes. Right. Then, so this question also find the finite region, the curve, integrate with this. So there's an important thing we have to understand in this fact of it. So if you draw this graph, it's a graph with the it's a cubic graph. Intersection of the x-axis are 0 over here because of this x minus 4 is 4. 4. Then they are referring to the graph. So you can say this is a turning effect is over here. The graph crosses at 0. It's just like this. and it comes to 4 and just turn over here and go with it. So now they are referring to this area. So how do you find this area, Pratik? So you can find this area by integrating the curve from where to where. Here the coordinate is 0, 0 to 4. 0 to 4, this one, Pratik. X times of x minus 4 squared. That is, you cannot straightforward do it. So if you expand this, it's turn up to x to the power 3 minus 8x squared plus 16x dx. That's the answer for that. Like that, you can do all these questions, right? Okay. Here, if you refer with this graph, you need to understand to do this integration. So you can integrate from 0 to k. So this question, you can integrate from 0 to k 3x squared minus 2x plus 2 and equating to how much? But they have given the area is 8. So by making it just like the same thing what I did over here, like this kind of question. So like this kind of situation, it's just over here, right? Like that you can get that answer. Right, and if you work out over here, you have to understand these coordinates. If you equate into the these coordinates, we should know. So this is 0 to 2. So simply for this answer, you can integrate from 0 to 2. This after x squared 2 minus x, then expand it. So it's turn up to x squared 2x squared 2x squared minus x cubed from 0 to 2. That is the answer for this question. Right. Okay. Then over here we need to find the coordinates of these two coordinates. So you know that at a and b the same thing what you did in the previous question. If you work out this question, you will realize that the coordinates become this way: minus 1, 2, and 3. That is 3 and minus 1. So here the coordinate is minus 1 and 3. So minus 1 and 3, right? Okay. So with that, you can integrate the curve from minus 1 to 3 and you can obtain this answer, right? That's a way of doing this question.